Let alpha beta be the roots of the quadratic equation. So I want to first write down that alpha plus beta is A and alpha beta equals negative B. Let Pn equal to alpha to the n minus beta to the n. So if P3 is that means I can write down alpha cube minus beta cube is negative 5 root 7I. P4 is that, so that's alpha to the 4 minus beta to the 4 is negative 3 root 7I. P5 means alpha to the 5 minus beta to the 5 equals 11 root 7I. And P6 means alpha to the 6 minus beta to the 6 equals 45 root 7I. Then I'm asked to find absolute of alpha to the 4 plus beta to the 4. I've been given alpha to the 4 minus beta to the 4, so I'm going to use that. So I can rewrite alpha to the 4 plus beta to the 4 absolute value as square root of alpha to the 4 minus beta to the 4 squared, and then I would get minus 2 alpha to the 4 beta to the 4, but I want plus 2, which means I will have to add plus 4 alpha to the 4 beta to the 4. Now notice this, I can plug this number, which is negative 3 root 7I plus 4. Now what is alpha to the 4 beta to the 4? Alpha beta is minus b. So when you take it to the 4th power, you just get b to the 4th power. And we can further simplify. When you square this quantity, minus becomes plus, 3 becomes 9, root 7 becomes 7. So you have 9 times 7 times I square. So that's negative 63 plus 4b to the 4. Now we don't know what b is. So that's where the other equations will help us. So notice I can write alpha to the 6 minus beta to the 6 in terms of this. So if I multiply alpha to the 5 minus beta to the 5 with alpha plus beta, then what I get is I'll get alpha to the 6 minus beta to the 6, but I will also get some additional terms, which is negative alpha beta to the 5, which means I have to do plus alpha beta to the 5, and I have a plus beta alpha to the 5, so I need to subtract beta alpha to the 5. So notice this is, now I can replace this with 45 root 7I, and alpha plus beta is a times this is 11 root 7I. And notice I can factor alpha beta. If I factor alpha beta, I would get beta to the 4 minus alpha to the 4. So let me factor minus alpha beta. Then what I get is alpha to the 4 minus beta to the 4. That way I can plug that in. So what I'm getting is, let's copy that, a times 11 root 7I minus alpha beta is plus b times, what is alpha to the 4 minus beta to the 4? It's negative 3 root 7I. So cancelling the common factor of root 7I, what we get is 45 equals 11a minus 3b. So this is equation 1. Call it equation 1. Now, as you can see, I'm interested in b, but I'll also have to solve for a. So I wrote this in terms of that. Now let's go ahead and write alpha to the 5 minus beta to the 5 in terms of the lower powers. So that's going to be, so you want to multiply with alpha plus beta, alpha to the 4 minus beta to the 4, and then what you want to do is you have additional terms minus alpha beta to the 4, so you would write plus alpha beta to the 4 just like we did here, and then you subtract minus beta alpha to the 4. So plug this in, 11 root 7I equal to, this is a, and this is negative 3 root 7I. And again, here you want to subtract, you want to factor out minus alpha beta. That way you would get alpha cube minus beta cube. So let's go ahead and expand this. You get a times negative 3 root 7I minus alpha beta is plus b times, what is alpha cube minus beta cube? Negative 5 root 7I. So again, remove the common factor of root 7I. You get 11 equals negative 3a minus 5b. So call this equation 2. And I'll leave it to you to solve those system of equations. So from 1 and 2, what I get when I solve, I get a equal to 3 and b equal to negative 4. So the goal was to simply find, so when you solve these two equations, you get a equal to 3, b equal to negative 4, and we're almost there. So this was this expression, which is square root of negative 3 plus 4 times b to the 4 is going to be 256. So this is going to be 256 times 4 is 1024 minus 63 is 961, and that happens to be 31. So that's our answer.